languages or the compilers which are used for the languages, where you will not be asked about for which platform or which target machine you are going to compile or build this project. But since it's a cross compiler, so it's going to tell you that you have to choose the proper target machine. Now I have to create a project. I have to choose a platform. So what I'll do is I'll go to the desktop. So I'll create a folder. Let's say this is the same thing. You can also do it. It'll be easy to manage your project files. So I've just gone to the desktop. So I created a new folder. So what is the name folder I can give? Let's say MCES in this case, MCES. So, or you can give your name, whatever there. Say, let's say I'm going to give my name here. So for 2021. So now what you can do is like this, you can give your USN number, then double click on that folder. Once you double click on that folder, it will go inside that folder. Then where you can give a name for your project. For example, sample is the name of the project I'm going to. It's not the name of the file. It's the name of the project. So where it's created inside the folder called KB 2021 under the desktop, which I've created it. Then say save. So the moment I save it, then immediately it will ask what is called as options it will give you. So now since it's a legacy device, that is the LPC2148 is not the software pack, it's not available under the software packs. You have to choose what is called legacy device. If you're not getting this option in the checkbox here, that means that you're not installed a legacy patchup file. So make sure that legacy patchup file is installed, then you will get that. Otherwise, you will not going to get this option. So I'll select the legacy device pack. See, these are the different companies who manufacture the microcontrollers, and the Keil gives support for the development of software for these microcontrollers. Choose any of the, for example, Cypress. You just click on that. See that number of microcontrollers are there available for that. Similarly, number of thousands of microcontrollers available for each company. If you look at the Cadence Design Solutions, you have a number of microcontrollers there. So look at Anchor chips, number of microcontrollers are there. Look at Altium, there are certain microcontrollers. Like this, so many microcontrollers are supported by this Keil platform. Now I am looking for one company called NXP Semiconductors. Either you can search NXP Semiconductor like this, you can search for it. So NXP, this is semiconductor. In this, there's a number of microcontrollers there. So I am interested in a particular one. You can choose like this, or you can type the name of that. For example, I want LPC2148. LPC2148 is a microcontroller we have selected for conducting experiments both in the lab, practically using this microcontroller kit, and also in the theory also we'll be studying with reference to LPC2148 microcontroller. It's an ARM-based microcontroller from NXP Semiconductors. And then I'll click on that. If I click on that, the features of this chip is shown. So this chip is manufactured by NXP. It uses the core, the CPU core supplied by the ARM company. What is the version of the CPU core? Is ARM7 TDMI-S. They will understand the meaning of each of these pins, each of these letters in the theory class. So it uses a core called ARM7 TDMI-S. Now onwards, any ARM microcontroller you're going to use or hear in your life in the future, the first question you have to ask is, if it's ARM microcontroller, which is a core used? Which version of the core is being used? That is the first question you should ask yourself. So which is a core LPC2148 uses? ARM7 TDMI, yes, ARM7 core it is uses. So the remaining things, apart from this core, whatever you see, apart from this one, yes or no? These are all the facilities provided by NXP Semiconductors, not by the ARM. These are all the peripherals chosen by the NXP company, and they put all these peripherals around the ARM7 TDMI CPU core, and then they manufacture the microcontroller. So some of the facilities, what this microcontroller provides, it's a 32-bit microcontroller. It provides 512 kilobyte of flash memory. It provides around 32 kilobyte of SRAM. It provides ADCs, USB support, I2C, so many things are there. We will study this in detail. So once you chosen the particular chip and identified the features of it, then say OK. So the moment you OK, it will ask one question, startup.s. When you say .s, it is nothing but an object called ASM file. It's nothing but an compiled ASM file, so which available as an object file. So it is telling that, shall I include startup.objs file, which contains the basic instructions or the startup code for this microcontroller? In the sense, whenever you boot, whenever you start the microcontroller which you used in your project, for this you are developing a software, automatically this startup code will be executed and initialize the basic things required for this microcontroller. Because every microcontroller, when you start, no, you have to do certain housekeeping things that either you have to write a code for that, or the ready file is available from the supplier of that microcontroller. You can use that one. Since in this case particularly I'm taking a no, because I am developing ASM based programs. In the ASM based programs, I want to start writing the code from the beginning myself. So only this is for learning purpose. But when you want to develop a project, so compulsorily you have to include this file. Since I am not downloading this code, whatever I'm going to learn using ASM programs onto the board now, I'm saying no. But in the lab, when you are developing the project and you're writing embedded C code and you're downloading this code onto the board, it is required, this file is required. That means that when you develop a project and download the project on the actual hardware, this file is compulsory required. Since I am just now simulating my program using ASM programs, I don't require. Say no for this. I'm audible?
Yes, sir.
Yeah. So now I have done the project creation. Now go and left side click the target. So now source group, there's a first group. Like this, you can have a multiple groups there. So for the target board, whatever you're going to now develop the project, so the source group should contain all the source files, whatever you're going to develop. So you can add all the ASM files, C files, everything. Since to start with, we will write the programs for this microcontroller using ASM. I will add the first ASM file into this group. How do we do it? So this, go to the file. This is what is called new option is there. Create a new option now. So before starting typing your code here, you give a name for this, the new file. Since I'm creating an ASM file, I'm going to give a name for that. So go to the either file option, then save, or you can use a shortcut. So I'm giving a name for this file. Let's say I'm giving as a test.asm or 1a.asm. I'm giving an option. So 1a is means that is a, let's say I'm doing the first a part of the lab program, 1a.asm. I just given it. Then I say save. Then what does happen? The name for your file is 1a.asm is going to be now given, and you can type your program here. Whatever the ASM program, I can type it here. Now, before you start typing the program, you can include this file into the source group. Go there, right click on that, add existing files. So select the files in the same folder whatever you created. Say KB 2021 is a folder where all my files will be created. So now just say what ASM file, select ASM files. Now it lists all the files, ASM files. Now I select the first one, then say add and then it. So then look at that now. So the ASM file will be created. So now once you have created that one, then what you can do is you can able to type the code what is required for this one. So what is required for this project file. Now what is a code you can able to type? To start with, you can able to type a simple code. So I will type the what is the first line and the last line what is required for that. So you give one tab space, then I will type everything in a capitals. It's not required you have to type in a capitals. It's a case insensitive assembly language program. You can type in lowercase or uppercase. So area reset. So since I've added this file to the project, I've added the file to the project. So area reset and the code, comma code, I've typed it. Now the last line of that after any ASM file will be end. Now look at this one. These are not the instructions to the microcontroller or the CPU core, whatever you are going to use. So these are the instructions to the assembler. That is what you have to do it. So I'm just defining at an area of a code. That means I'm just telling that this is a code to be executed after the reset. So I'm just telling that whatever I'm going to place between these two statements is a code I'm going to put it. Now I'm going to do two things. So I'm going to define an entry for that. So wherever the entry is a keyword, so there is assembler directive, you have to place it. So below the place where the code is supposed to execute it. Now I will write one instruction. So move, let's say R0 comma hash 3. So I've just written one instruction. So the instruction, what it does is it will move into the register. So one of the register into the 4, any of the registers. So move R1, R0, any register I can able to use it. If I want to change the register, I can just go there. I can just change the register to R1. Any register I can be able to give it. Now, I don't want to write any more instruction, or you can write one more instruction. Say move R2 comma hash 5. I will write it. Then I can able to do some addition after that. I'll keep the answer in R3, then R1 comma R2. So I've just added the two numbers which are there in R1, R2, store the answer in R3. One of the feature of any assembly language program is after you execute your program, this was I was telling in the case of a Arduino program also, after you run this program, the control is goes to where? There is no operating system is there in the ARM microcontroller board what I'm talking now. That means that as soon as you finish your program execution, where should return? No place to return because there is no voice is there. So that means that once you finish your job, you should write a loop program continuously. You should loop there only. You should wait there indefinite wait. Whereas in Arduino Studio, they've already organized in a proper way. They have given a concept called setup and a loop because it's a very at the abstraction level. They have done certain abstraction. On that abstraction, you are working at a program. Here, there is no abstraction. You are working at a very low level. So not the comfort of Arduino Studio will be there for you. You'll be working at a very low level. That means that just the microcontroller is there. On the microcontroller, you're working development. Whereas in Arduino, what will happen? Microcontroller was hidden. Hidden by what? Arduino board, Arduino Studio. So Arduino Studio, the Arduino board has done a lot of abstractions. A lot of things they have taken care. It just to give a very user interface to develop your projects. But here is not like that when you develop on your own very low level code. Because why? So you will be given only in the mind microcontroller. There is no studio, nothing is there. You can just write your code and put on the microcontroller chip. No board is there. That means that very low level. That means that it allows you to design your own system the way you want when you know abstraction is done. So that means that you have to know very small details about the microcontroller, very subtle details. So finer details you should be able to require to know. So now there is no concept called setup and a loop is there. So whatever you want to do, you have to do yourself. Now what I have to do, I have finished execution of this instruction. Now if I don't write anything here, what will happen? My program counter, so I'm just introducing the low level things now. I'm using a word called instruction pointer program counter. If you don't do, what will happen? After executing this instruction, program counter and instruction pointer goes to the next instruction and keep executing that. If nothing is written in the memory, what will be there in the memory? Some junk code, unwanted things will be there in the memory. Whether you store or not, it will be there. So it start executing that unwanted code in the memory. So even though you're not written anything, so what will happen? Unexpected things happen in from the microcontroller side, and you're going to do certain things which you are not expected. So for me, what I want to execute this statement and stop executing it. Nothing should happen after that. Yes or no? Only you should execute this meaning. These meanings you should execute. After that, you should not do it. You should not do anything. Means what does it mean? That you should not allow the microcontroller to go below this line. Even though end is there, end is not an instruction. End is a instruction to an assembler saying that these are the statements to be assembled. That is converted into machine code and put into that one. End is not an instruction. There is no instruction called end to a microcontroller say that you stop here. So there is no way of stopping a microcontroller. Microcontroller is always what? till what point you able to follow it?
Sir, before stop.
No, till what point?
You're talking
Before
about the
the
loops.
stop. Okay.
Sir. So you're talking
Okay.
about loop.
So, okay, this is the, yeah. So this loop is required. This is the nature of every embedded system. That is, after finishing your task, what you're supposed to do, it be in the loop so that it will not execute any junk code which is present after that. So now I've written my sample ASM code. So here the instruction to the microcontroller only, these are the instruction to the microcontroller. So whatever here I've written these, and the last statement, it's not instruction to the microcontroller. They are the instruction to an assembler. Assembler is a software provided by the KEI, so which gives instruction to the assembler. That means that these are the two lines which says that following instructions to be assembled, converted to machine language, and to be executed by your microcontroller. That is the meaning it carries it here. So these are the actual instructions which are being supplied for this microcontroller. Who supplies this instruction? Who designed these instructions? It is designed by the ARM core, that is ARM 7 core, for which the ARM company has designed the instruction. So whoever supplies the CPU core, they will design these instructions actually for that. Am I audible?
So can you repeat what the sixth line stop does?
No, stop, this basically is a branch instruction. It says that branch to stop. Branch to stop in the sense it will be repeatedly execute this. So branch instruction is available to jump to any place in the program. Now where I'm jumping to the same place. So that means that it is nothing but the statement is equal to while of one and indefinite loop. This is basically, this statement is equivalent to this one. So I'm in an indefinite loop. Why I'm in an indefinite loop? Because I finished my job. I don't have any job to do now, but I should not allow the microcontroller to go down and execute some junk code present in the memory. That is why it's a indefinite jump. Here I put
Okay.
it here. Is it clear?
Yes, sir.
Is it clear?
Yes, sir. Clear, sir.
Hello.
Yes, sir. It's clear.
Is it clear?
Yes, sir. It's clear.
Yeah. Okay. So now what I have to do, I have to do certain settings in the this project. Go to the settings. Any settings is there provided called options for target. This is the place called options for target. So click on the options for target. Certain selections you have to make it. One is micro lib. This is the first selection you have to make it. So then say OK. Then some more selections you have to make it. Go for the options. Again, go for the options. Go for the options. Then select the debug or linker. Use memory layout for a target dialog. Then say OK. Am I audible? Hello, am I audible?
Yes, sir.
Rishal, am I audible?
Yes, sir.
Yeah, okay. So now I have done the two settings. What are the two settings I had done? I have gone to the options. In the target, I just selected use micro lib and then gone to the linker and selected these options. Then say OK. Now all these things have done it. I have just selected a file. Now this is the place where the compiling or building an option is available. I'll just rebuild this one. See that any. So now the 0 errors has come and one warning is there. That matches with a window. That's it's anyway warning. Okay. Now need not worry about that warning. So now this program is being compiled. So I have created a project. I created one ASM file. Make sure that you give a tab space. You have to give a one tab space for typing these instructions. So don't type the instruction from here only. You will get an error. Type, give one tab space for your instructions and then type the code. So this spacing is required in the beginning. After you type, then compile your programs. Once you get a 0 errors, that means that program is ready. You can able to run this program and test your program in your compiler. How do you run this program? I said this Kyle provides what is called simulator. Using the simulator, you can test your program is working or nothing but. Simulator is nothing but a place where you can able to execute step by step and can go inside the ARM core and see what is happening inside the ARM core. You can understand the ARM core in a very good way, in a very better way. You can appreciate the ARM architecture when you execute the instructions step by step using a simulator. Am I audible?
Yes, sir.
Yeah. So now how do you run a simulator? This is the simulator. So click on that start debug. Now, once you click on that, then it opens up the whole of the inside architecture of your ARM core. I said in the morning, what is the ARM core contains inside, the CPU core contains inside. The CPU core, the CPU ARM core contains inside what? The set of registers. One of the basic building blocks of a core or inside the CPU is what is called as a set of registers. So how many registers were there? I was telling in the morning, there are about 16 registers there. They are called as R0 to R15. These are the registers available. We will explain these registers, the different modes, whatever you have. These are the different modes of the ARM microcontroller. There's a program counter, there's a mode, these are the states. So many things are there. So we will have one session, probably theory session on Wednesday about this, how understanding this one. Now my focus is on only what will happen when you execute these instructions. For example, first instruction, what? Move R1 comma 3. Look at R1. What is the value in R1 now? 0x00. That is 00. Now I'll execute the instruction. How do you execute the instruction? You can execute the instruction step by step. See, step over is there. That is step by step. You click one time this one. Then what will happen? This instruction is executed. Now it will go to the next instruction. See that what will happen. Now R1 contains 3. That means that first instruction is executed perfectly, and inside the core the value whatever is specified 3 is moved into the register called R1. Now what is the second instruction? R2 comma 5. So now R2 is 0. I'll execute another instruction. Now what will happen? The 5 whatever you written here is goes into the R2 register. Now we are going to add these two numbers. What are the two things you are adding? R1 comma R2. So what does R1 contains? 3. What does R2 contains? So 5. So that means that R1 and R2, 5 plus 3 is added and the 8 is placed in the R3 register. So now I just execute this statement and it is placed in R3. So R1 plus R2 is added and it is placed in the R3. So the 8 is there in the register. So now after this, what will do it? So if you keep on executing this one, it will be here only. It will not go to the next step. See, it will be here only. Because why? This instruction meaning is what? Come back to here only. Come back to here only. So it will be here only. This is how you have to run your program and test whether it's working or not. Compile it. Then I'll stop it. How do you stop it? Then say again you click OK and debug on that. So now it stopped executing it. So this is how this program is to be written in assembly and to be executed. Any doubts? You tell me now.